So thank you all for joining today's webinar. The topic will be, as you know, QoS and QoE monitoring strategies for sports and eSports streaming. While we talk, feel free to pose your questions in the Q&A bar, and then at the end of the session, we will answer them and address with the help of Dimitri and Ilya. So let me share my screen. So in today's webinar about monitoring strategies for sports and esports streaming, participants will be Elecard, which provides solutions for video compression, for video quality analysis in offline mode, and also real-time monitoring of QoS and QoE parameters. Also provides live encoders and packages, which are in production with tier 1 and 2, 3 broadcasters, OTT operators, and IPTV. Okay, sorry for the inconvenience to you all. So as I was saying, in Elecard we provide Elecard provides live encoders and packages for tier 1, 2, and 3 broadcasters, for OTT and IPTV operators. Today with us, we're supposed to have video labs as well, but due to some unforeseen circumstances, Todd was not able to join us. Then we have Diantis System House, which is a broadcasting system integration and distribution company headquartered in Canada and operates from North America and the CIMA region. So maybe Ilya, would you like to tell us more about your company?
Yes, we are offering broadcast system project design, system integration and installation services, as well as export and distribution of broadcast IT, telecommunications, and cinematographic systems and equipment from various Canadian, US, and European manufacturers. That's just in a few words.
Mm-hmm. Thank you. Okay, so you already heard from Ilya. So he's the sales and marketing director from Diantis System House, and with us as well is Dmitry Ivanov, who is lead engineer of technical support team in Elecard.
Hi, everyone.
Mm-hmm. Great. So let's move on to the agenda, okay, for today's webinar. So starting from an overview about broadcasting both for sports and esports, then we will dive into the specifics of low latency broadcasting. Afterwards, we will discuss more in detail protocol choice for ultra-low latency. And then finally, but not last but not least, we will see some success stories from both the Diantis System House and Elecard. So let's have a look at the esports and sports scenarios. So nowadays, there is nothing out of the ordinary in watching concerts and ceremonies or sports in live mode, right? Even if they are thousands of miles away from where the viewers are located, right? But what is happening lately is a more important presence of esports, not only on those platforms like Twitch or YouTube, which are well known for that, right? But also on traditional TV channels. So maybe, Dimitri, can you please clarify about esports and sports scenarios looking into this?
Yeah, sure. Yeah, I agree with you that recently the esports gained great popularity, and nowadays there are nothing strange to see these programs about esports events onto the traditional TV and linear broadcasting platforms. However, usually they were using some specialized platforms like Twitch or YouTube, but now its popularity spread widely. So, and originally the esports solutions were trying not to use some legacy equipment and protocols. So, because there are no track records for that, and one of the recent direction is to use the cloud-hosted production platforms for esports and sports streaming as well. But comparing to the sports streaming solutions, there are some like legacy hardware equipment, and there are some other specific requirements which are referred to the traditional sports platforms. So this is the main pinpoints and the main features of sports and esports comparing to each other.
Thank you. Yeah, what is your experience regarding the increasing of esports popularity?
Definitely, pandemic made a significant contribution in the increase of online transmissions on the streaming events, all the streaming events, and especially sports events as well. And for the last 2 years, although some of the venues were cancelled, but after they were allowed to go without any spectators, without any viewers. So the only way for them to see the matches of their favorite teams were online. So, and this made a huge contribution to increasing of the transmission of live sports events.
What about you, Dmitry? What is your experience on this?
Yeah, I'm pretty agree with Ilya here, and so due to the pandemic, we have to change our habits greatly, and so the pandemic make us to participate in more to spend more time indoors compared to the previous times. And when we are seated at home, we doing the same things differently. We started to use other streaming platforms. We started to pay more attention to some sports or esports, and of course, this brings lots of new challenges to all of this field. So, and yeah, let's discuss about it.
Yeah. Can you tell us more about the challenges, and maybe you can introduce us to this scheme?
Yeah, sure. So this is the esports principal scheme, where there is since the esports is a fairly young field, there are no track records or the specific equipment and protocols for broadcasting as there is for traditional sports events. And as I said before, companies is trying to use the most up-to-date delivery protocol, since as esports events could combine participants from different points of the world, like the teammates might stream from even different continents. So that is why there is a challenges to stream to choose the right protocol for this streaming. And of course, there is a challenge to do the streaming through the public networks, because as you may see on this diagram, the production cloud platforms are usually being used for the eSports principal schemes. So that is, as I said, is really challenging to provide the reliable transport and provide the reliable and provide the high level of experience, of user experience, keeping in mind all these challenges. And yeah, for the end platforms for the esports, the mainly are the YouTube and Twitch. So, which is quite different compared to the sports principal schemes.
Mm-hmm. Maybe Ilya can tell us more about sports schemes.
Ilya, your microphone is muted.
Thank you very much. I would like to get this on the example of Canadian Hockey League live streaming architecture. Streaming to previous examples, cloud production platforms delivery is the primary target that appears right after the content is being filmed. In the CHL case, RTMP protocol was chosen by CDN, not by Canadian Hockey League. Usually the content distribution network dictates you the standard you have to use. And it was done after unsuccessful experiment with RTMP with forward error correction in the previous season, where the venues were struggling with different encoders. I wouldn't mention the name, but they were overheating. They had a lot of distortions, macro blocking, so we have to replace. And the protocol itself did fit very well. And although this season was on RTMP, in the future it will be switched to SRT, which compensate for unreliable internet connection at some venues with 25% lost packets recovery rate. And looking at this diagram, we can see that cloud-hosted AWS platform or slicers receive RTMP stream from primary encoder during this year, and as I said, next season it will be SRT, and receives from primary encoder and transcode this, and CDN transcode this to HLS and a backdash to deliver the streams to such platforms and services as CHL website and CHL TV app on Apple TV, Amazon Fire, Roku, iOS, iPhone, iPad, and different things. So this is overview of a diagram of the streaming of Canadian Hockey League.
So I see that there were a few pain points for the displays that have been solved. Maybe let's take a look at the general scenario. So what are the pain points to focus on when making a technological choice? Dimitri, maybe you can give us an insight on this according to your experience as well.
Yeah, sure. Yeah, if we are talking about the sports or esports streaming, one of the major points that we have to pay our attention to is the latency, because of course, if you are watching some interesting event to you, you would like to be on time when your team scoring the goal. So you wouldn't like to hear the scream of your close people that were looking the same program but know the result first compared to you. So the latency. What is the latency? In general terms, is the time difference between the particular video frame being captured by the camera and the time when the frame is played by the on the display of the end user. And there are lots of challenges that brings the latency level. I mean that the low latency should not reduce the quality of stream transmission. So, which is mean that we have to have at least minimum buffering to afford our transcoder do some interprediction, and that increases the quality. And another thing that we should pay our attention to is the guarantee delivery, because each lost packet will definitely result in quality degradation for the end user. And of course, this will reduces the watching experience drastically for the end user as well. And as we previously said, more and more services switch to the cloud technologies. So it allows to save on rented premises, electricity, hardware, and this is increasing the requirements for low latency as well, with the high RTT, which is the round trip time. Then this is especially meaningful for transmitting high bitrates during HD and UHD video broadcasters. And for example, if the cloud server is located in the United States and the content consumers is located in Europe. So, yeah, Ilya, my question to you: what do you say about the latency requirements in your like workflow, daily workflow? Do you have some, or maybe you can elaborate on the level of latency you have with your equipment?
Latency of delivery the signal from the venue to Verizon Digital Media or Yahoo Edgecast. By the way, they have a new name today. I think it's Edgecastio, something like this. They changed the name twice. This is hardly noticeable because we can see the signal from the encoder on the slicer, on Amazon Web Services slicer almost right away. But transcoding process from RTMP to HLS and MPEG dash takes up to 1 minute. So the viewer will see the delay of 1 minute, but of course they cannot see it. They see what it's available to them, but we can see that it takes 1 minute for processing of this and transcoding of the signal. So that's why it's not, I mean, we cannot complain about latency of delivering the signal from us to Amazon. It's quite fast, but transcoding process is what takes time.
Mm-hmm. Interesting. How does the choice of protocol affect the performance in terms of latency then?
If it's a question to me, as I said earlier, I mean, we would be great to, our encoders, they support all existing formats, streaming formats and protocols, but very often CDN or content delivery network dictates you what streams they can receive. So sometimes it's not a sport league decision or technical decision. It's what the infrastructure can offer you. You're ready to send SRT stream, but they're saying, no, we haven't deployed SRT slicers in Amazon Web Services yet, so we have to do it. We have to take time and test it. We cannot deploy it right now. We need time. We need half a year or something like this. So, and we stream what CDN can accept. We use this protocol which CDN can accept.
I understand. What about you, Dimitri? What is your insight on this? What could you please comment?
Yeah, sure. So yeah, we have lots of experience in different projects, different streaming architectures, and different protocols using. So, and there are some projects where the main requirements is the latency, as we said previously, which is one of the main like requirements for some of the projects. And of course, for this project where there is a question to provide with the required level of latency. The choosing of the proper streaming protocol is really this question is really like challenging. So yeah, I would like to give a little comparison between the three protocols. So just a little note that here we will talk about the most common delivery protocol capable of providing ultra-low latency levels within lower than 1 second over the public and non-public networks, but not cover the traditional HTTP-based HLS or MPEG-dash protocols, which in the most recent low latency implementations could provide close level of latency. But we would like to compare these three ones. So first, and probably one of the most widely spread protocol is UDP, which is probably the first technology that was widely used in modern television broadcasting, and associated with the term low latency was multicast broadcasting with MPEG transport stream content via UDP. And typically such a format was chosen in a closed and loaded networks where the probability of lost packets was minimized. Then the SRT came up. This protocol was designed for low latency video transmission over public internet. And SRT was originally developed by Haivision company to use in their own encoders and decoders, but in 2016 it became an open protocol for real-time video delivery, and this protocol operates on the basis of the UDP-based data transfer protocol, a well-known and proven file transfer protocol. And UDP is significantly faster than TCP, and it's easily configurable. And last but not least, the RIST protocol, which is based on the RTP and RTCP and SMPTE 2022 protocols. And it was originally developed for streaming video content, and it incorporates much of the experience gained in the developing the earlier open and proprietary streaming protocols. And so yeah, let's go by the protocol functionality first. Let's start with the latency, which we discussed as the main pinpoint. Leah, can you please switch back to the previous slide?
Sorry.
Yeah, sure. So the minimum possible latency level that could be achieved by with the using of UDP protocol is 80 milliseconds in terms of 25 FPS. And some companies achieve this level of latency associated with the encoding, data transfer, and decoding over Ethernet. And with a higher frame rate, this characteristic will be even higher. Even less, the latency less. And what I can say that similar solution was used at the Confederation Cup at 2016 and the FIFA World Cup 2018 by Elecard. And by the principal scheme was the modulator, distributed DVB-C network, and TV set. So Leah, can you please go back to the previous one? No, I mean to the slide number. Yeah, this one. Yeah.
This one.
Yeah, this is the kind of a principal scheme for this solution, and the entire total latency of this scheme was about 220 to 240 milliseconds. And yeah, on this diagram, the elements such as camera, HD, SDI transmission, IP Ethernet transmission, modulator, and RF networks has fixed latency, but the main field for creative settings is the encoder, where we can do our experiments with the settings, but its latency cannot be lower than 40 milliseconds, assuming broadcasting is with FPS equal to 25 frames per second. Since there must be at least one frame in the buffer in order to encoder to use their predictions. And of course, these predictions will allow to has really a low latency and increase the video quality by inter-predictions. So let's get back to the next slide. Yeah, for the previous one with the latency. Yeah, thank you. For SRT, the developers claim that the minimum latency that can be achieved when using SRT is 120 milliseconds, with the minimum buffer when transmitting over short distances in closed networks. But the total latency recommended for stable broadcasting is 3 to 4 RTT. Besides, SRT handles a long distance for several thousands of kilometers and high bit rates, 10 megabits or higher delivery, better than its ancestor RTMP. And RIST, in terms of latency, is similar to SRT, but this protocol has some advantages, such as RIST supports broadcasting in IP multicast mode, which significantly saves traffic and network resources, as well as the UDP, which is support broadcasting streaming, but SRT do not support this feature, and this is sometimes crucial. So this is the really crucial feature to have. For instance, for monitoring, so we are pretty we oftenly see that for monitoring, we used to monitor multicast streaming for UDP or for RIST, but to monitor SRT, we have to, as SRT is kind of point-to-point delivery protocol, we have to arrange the standalone session to monitor it, and it could be, this session could have different parameters than the original one of our interest. The next main feature is the lost packet retransmission mechanism, which is not supported by UDP, of course, because the UDP is unreliable transport protocol. So, and it was designed, as I said, for data transfer in closed networks, where packet losses are not so oftenly could happen. But for SRT, this SRT and RIST, this mechanism are supported, and for SRT, the its features, it features to perform well with a low or average percentage of packet loss, no more than 10 or 12%. However, RIST can RIST can recover from losses up to 25% of packet losses with 100% of overhead, and up to 50% of losses with 200% of overhead. And RIST can recover up to 86% of short-term packet losses, which is significant. So the next, like the main feature I would like to pay my attention to, Leah, can you please step forward? Yeah, is the forward error concealment support, which is again not supported by UDP but supported by SRT and RIST, and security, and an encryption feature, which of course is really crucial for data transferring over the open networks. For SRT PSK algorithm is supported. For RIST, DTLS or PSK are supported. And the last but not least is the compatibility with the legacy solutions. So as I said, the UDP is one of the most widely spread protocol, and of course it's compatible with the legacy solutions, and RIST as it is based on RTP protocol. So if the legacy hardware supports basic RTP, it could handle RIST in legacy mode, of course, without the security encryption, packet retransmission, but basic support still be available. However, SRT do not has its functionality and do not compatible with the legacy solution. So this is the like the quick overview of the main feature of these protocols. So yeah, question to Ilya. As you noticed that SRT and RIST has pretty similar features, but according to your thoughts, what do you think is the more promising protocol for future?
I'm pretty sure that most promising protocol is the one which can recover the most lost data. In this case, it's RIST. Up to 50% losses can be recovered, and this is a big deal for many venues who cannot afford maybe second encoder to send main and backup stream, but they can definitely send 200% overhead, so they can stream a little bit more data from the same encoder and hoping that the data will be recovered, because viewer experience is what is important in the electronic sport. If you have distortions and macro blocking, so of course the viewers will complain. So if protocol can recover some of the lost packets, it's great. It's the future, because the difference of eSport is a broadcast that it uses just public internet, where packet losses are a normal thing.
So this is another pain point, according to your point of view, when choosing a streaming technology, to understand right, like to make sure that there are no packet loss. There is no packet loss within the stream.
There is always packet losses in public internet. You cannot avoid this. Just you have to choose the protocol which can recover more losses. That's why I'm saying this is probably the future protocol.
Then, make okay. How can
Back
you?
to Dmitry.
Can you check it? Okay. Dimitri?
Yeah, go. Sorry, can you repeat, please, the last sentence I missed?
I mean, I'm asking what are the other pain points, according to your experience, that you have to pay attention to when choosing streaming technology. And Ilya mentioned packet loss. So, is there anything that you should take in consideration to, let's say, face that issue?
Yeah, sure. There are lots of challenges, lots of things, and from my point of view, that always when it comes to protocol choosing for testing or for implementation of any solution, there is a challenge how to like check whether your scheme, whether your protocol, whether your equipment operates correctly. And here monitoring came up. So yeah, which is from my point of view is really crucial pinpoint. So when it comes to live event broadcasting, and especially with the low latency, it is crucial to have a tool at hand that is addition to problem reporting allows to prevent malfunctions by notifying about events that may lead to problems quickly, conventionally, and in much detail. And of course, in really large-scale projects, always there are a large number of vendors that could be reliable for different places of the delivery of your entire chain. And it is really useful to have a tool to be able to distribute its responsibility between them, because sometimes when you have really distributed delivery, it's not obvious who is to blame in some problems, some issues. And when you have additional eyes, like monitoring, you can easily localize and define who is to blame and who should put efforts to fix issues. And yeah, the more information about the state of channels is available, the better. So it seems to be really obvious, but it could be also challenging because if this information is useless, so it's always useful to have the tool that could provide the information in a smart way that allowed engineer not to waste his valuable time on diving deep into this information. So yeah, this is on this slide we have the monitoring scheme, the principal monitoring scheme that could be provided and could be implemented with one of our solutions called Elecard Burrow, which is monitoring tool. And the probes could be distributed across the delivery chain. It could be located at the DVB or IPTV provider sites. It could be located into the studios too. Check the SRT delivery quality before the transcoder at the transcoder output to check the transcoding quality, and even be distributed to the IPTV consumer premises or to the CDN region servers or regional edge servers. So this is the really powerful and distributed solution we may implement, and we are often used to monitor all distributed schemes for our customers.
Ilya, what is your experience with monitoring, on the other hand?
We use Elecard Burrow, like CHL-TV uses Elecard Burrow monitoring tool, which I would like to discuss a little bit later, and I will explain why we, I mean, CHL-TV would like to monitor RTMP stream, which is coming at AWS slicer. First is to make sure that the connection between venue and AWS is good and there are no dropouts there, and then to monitor what is delivered to consumers, to the viewers in HLS and MBEC-Dash. But I think at that time RTMP was not supported in Elecard Burrow, so we had to monitor only HLS and MBEC-Dash. but with transmission to SRT would be great to add this additional probe at the input of the transcoder, and we will monitor both what is incoming signal to AWS and what is the outgoing signal from CDN to the consumers.
Yeah, just a little note from me that we just recently implemented the SRT support in Elecard Borough. So as I said before, and now we could offer for our customers the additional point for data sampling that will definitely help to cut off some probable SRT quality of service issues. And so, yeah, we can jump.
I think we can jump onto, to go more in detail into the EA and CHL TV challenges and use cases. So here is the scheme for EA of the solution that has been implemented. Dimitri, you have worked directly with them, so I mean the floor is yours. Explain more about how Elecard helped EA in their challenge.
Yeah, sure. I was supporting this customer, so I will definitely have some insights regarding that. So we implemented the distributed management method. Borough software probes were installed on the production cloud platform at the output points of encoders, and as well as across the CDN. So yeah, when we were doing this, the customer said that ideally it would be great to have probes at the input of the encoders to cut off the transport defects. But since they are using SRT RIST or RTMP, we couldn't help them at this time. But now, as I said, we have added the SRT support, so I believe they will add the probe on the cloud on the ingesting of the transcoder to cut off these SRT probable issues. Yeah, returning to the scheme, the probe on the production cloud platform is responsible for monitoring quality of content prepared for distribution. So at this point, it is important to monitor both the syntax, quality of system level, errors, and the level of perception quality, which is the quality of experience level. Problems such as freezes, stuttering, frame drops can be effectively localized with the right tool, for example, Elecard Borough, as we said. But CDN monitoring applies more attention to the transport level. So we installed the probes on the CDN. For CDN, it might be Borough might be useful to track some connection transport issues between the origin servers, edge servers, or the final destinations. And Borough is able to give a complete picture of what is happening and evaluate operation of the entire CDN service.
Thank you. And here we have Diantis scheme. Is there anything you would like to add, Ilya, to what you have previously already explained?
Yes, as I said, in CHL case, CDN output monitoring option was chosen. So the prepared transcoded content is being monitored right before the end user, delivery to end user, and this is the same what is delivered to end user, so it's very valuable. And the main result of using that scheme is that we could identify the deficiencies in the venue's internet connections, throttling, insufficient bandwidth, line drops, or production equipment problems sometimes on the input of the encoder. And this can be identified 1-2 hours before the game start, and CHLTV could implement backup measures where something is available. And also it helps when troubleshooting production equipment, encoders, internet modems well in advance. So in this case, it could be fixed before the game. But with with transition to SRT protocol, the SRT monitoring will be added to the probe, and it will allow CHLTV to monitor incoming signal and outgoing signal, let's say, right, before transcoding and after transcoding, I would say. And the problem can be identified if it's a slicer problem or if it's a venue problem, internet connection problem. So, and as a primary monitoring data, there will be live view monitor showing all good streams in green, packet drops of HLS and the backdash streams in yellow, and freezes in blue, and signal losses in red. So it's very easy for operator to identify the problem and see the streams right away and switch to backup feed when it's available. And of course, it's very graphical, very easy for every operator to understand, and especially very helpful to monitor. Sometimes there are 20 games at the same time, so one operator can monitor several games and identify the problem at a particular venue right away.
Yes,
and just testimonial from CHLTV is they have chosen Elecard Bora for easy to use, affordable price, and many monitoring, analyzing, and even recording tools. So you can, in case of problems, they could record the stream and then show it to the venue and show them what was delivered to the viewer. If venue was saying, no, everything is good on our side, and it's good, like proving tool. And they will especially appreciate the live view that allows them to identify the problem with the streams right away and switching to backup feed if needed. And as a result, the stability of all the games in the middle of the season had an exponential increase.
It looks like they gain great benefit from the monitoring tools. So it seems
yes. Otherwise,
it's really necessary.
I don't know how else they would be able to monitor 20 streams at the same time by one operator.
Yes, also because it's everything is. I mean, you get notification in case of errors, so you can.
Yes, and it could be notification could be sent. Yeah, also it's several views. It's like multi-viewer view. You can see all the refreshing thumbnails on one screen, or you can see the like moving graph, like a stream, and you can see if it's green or yellow or blue or red, and you can see the problem. Unfortunately, because of the 1 minute delay, only when it happened after 1 minute delay, operator will see this problem. And this is the nature of HLS and backdash transcoding.
So the tool will help you also to prevent such issues, you know, and
yes, exactly.
that the end user will experience.
Yeah, especially before the game, like if he can, like if his HLTV can see the unstable internet connections, they can advise to reboot the modem or just switch to different modem or do something else, or to power cycle the encoder maybe even. So they can do some measures in advance, and this is very important to monitor everything before the game.
I totally agree. Totally agree. Dimitri, would you like to add anything to the discussion?
Yeah, I totally agree with all the points, because it's really like the kind of feedback from our users, and we always value the feedbacks from the customers.
Okay, so I would suggest to move on to this was the use case from Vidian, to the Q&A section. I see here that we have some questions. Was it convenient to monitor streams from different points, and how did you get notifications? So Dimitri, would you like to answer?
Sure. Yeah, as I said previously, we designed our tool for distributed monitoring, and the great feature is that you can distribute your probes across your delivery network in different points and collect and have all information in one place, combine necessary streams in in necessary views, do filtering, add in text, and etc. And then you can create different profiles and choose different notification systems to notify with the most relevant and most useful way. Like we have email notification, SNMP notifications, Telegram, push HTTP notifications, which is webhooks. And integration with the pager duty, so you can create different profiles for different type of users to get proper notification into the proper place.
Mm-hmm. So Tadeusz, did you receive all the answers that you requested? Let's see.
I can see one question in the chat. How do you see?
Oh, yeah.
How do you see up to 50 streams? 15 streams. Does Boro receive all 15 streams? Yes. Boro is operates like an ordinary player, so it's like receiving the stream and do the analysis on the probe side and sends the statistical data to the centralized server. So there are some advanced quality of experience parameters for monitoring, such as video freezing, audio loudness and audio silence, thumbnails capturing, and video quality measurement, our own designed EPSNR metric for video quality measurement without the reference.
Tadeusz is saying, thank you almost. Do you provide API to integrate your data to existing solutions?
Yeah, this is the rather frequently asked question. Yeah, we do have an API which comes with our on-prem solution. So we do have two models of providing monitoring. First one is the cloud service, where we host a centralized monitoring server on our side, and you just need to deploy software probes on your side. And the second one is on-prem mode, where when we provide the entire software probes and software server to be installed on your premises. It could be located within your LAN, totally without an access to the internet. And for this model, we provide the API that allows to interact with the existing solution to start to manage the task, to manage the probes, and to request information about the running streams, about running monitoring tasks.
Understood. Any other question? Please feel free to, we still have some minutes. Okay, 1 minute actually. But let's see if anybody writes. don't be shy. We're here to answer to all your questions, and that's it. Okay, you're welcome to those. Let's see.
Thank you very much for participation.
Yes, I think you
So
can
I have to
resume.
drop off.
Yes, thank you all for coming to the webinar. It was a great chance to go deeper into the monitoring architecture, and I hope it was useful. You can reach out to us, and you can see here, the email address. You can send your request. You can register. You can ask more questions about monitoring and about protocols, and we'll be happy to help and to answer.
Yeah, I see one more question in chat.
Question, yes.
I'm pretty sure that we will send the recording like sometime after the webinar. It will be released or send it.
Yes, you will receive it. Okay, so I think if this is all, I think we can resume. And thank you again for joining, and see you soon, I guess.
Thank you. Thank you all.
Thank you, Dimitri. And I don't know if Ilya is still here. He left, but thank you also, Ilya, in case.
Thank you.
Thank you. Bye.